This is my Physics 2010 project number 2, and it is over understanding convection, conduction, and radiation, and each of their individual methods of heat transfer, and it is by me, Whitley Pollard. Okay. So, our initial question is, what is the purpose of convection, conduction, and radiation? Well, convection, conduction, and radiation have a common purpose, and that is heat transfer. They each have their own individual methods and system of transferring heat, and I'll begin by discussing convection, but I will also individually discuss conduction and radiation. There will also be examples given to demonstrate these concepts better for understanding and learning. Okay, so our first question about convection is, well, what is convection? Well, convection can be defined as the transfer of heat by the circulation or movement of the heat parts of a liquid or gas. Now, there is another way of defining convection, and that is the movement of molecules that carry heat along with them. So, our second question about convection is, how does it work? Well, when a liquid or a gas heats up, it becomes less dense because the molecules become excited and they aren't as compressed when they become excited. Once they are heated up enough and once they reach a lower density due to the heat being applied, the heating molecules will begin to rise, such as air in our atmosphere. When the heated molecules rise upward, cooler molecules, which can be also defined as cooler air when you think about it, they will rush down to take the place of the heated molecules or the heated air. This is a continuous cycle, and it happens continuously in our atmosphere. Okay, so our last point about convection are examples. I'm going to talk about the two examples that I used in my essay because I feel like they demonstrate the concept of convection very well. So the first one that I discussed is boiling water. So when you boil water, the hotter water is at the bottom of the pot. So this also means that the water at the bottom of the pot, once it gets hotter, will become less dense. Now, when it becomes less dense, those hotter molecules will rise to the top, and the cooler water molecules will sink to the bottom. And when they heat up, they will process, it happens like a cycle, so it's continuous. So the bottom hotter molecules will rise to the top and the cooler ones will rise to the bottom, and it's a continuous cycle. The last example is a hot air balloon. So when you get in a hot air balloon, the pilot will turn hot air on, and the hot air will rise and gather underneath the balloon. Because this hot air gathers underneath the balloon, as we know, heat rises. So when it reaches a certain temperature and enough heat is gathered underneath there, the balloon will rise into the air. When you want to bring the hot air balloon back down, he will turn off the hot air and it will be replaced with cooler air. So the way this displays convection is because there's hot air, the cool air will rush in to take the place of the hot air. And once this happens, the balloon will slowly start to fall. And this is a great example of convection as far as cooler air taking the place of hot air. Okay, so the second term to be discussed is conduction. And our first question, as with convection, is what is conduction? Well, conduction can be defined as the transfer of heat between two parts of a stationary system caused by a temperature difference between the parts. Since heat is energy associated with the motions of the particles making up a substance, it is transferred by such motions, shifting from regions of higher temperature where particles are more energetic to regions of lower temperature where they aren't as energetic, if energetic at all. Okay, so our second question for conduction is how does this work? And I'm going to combine the question, how does this work, with the question, what are examples, because I'm going to use an example to describe how it works. So, on the molecular level, what's happening is when heat is applied to something, so my example is going to be a frying pan. When heat is applied to this frying pan, the molecules that make up the pan directly exposed to heat will get excited and start to collide. So, once the collision of the originally excited molecules, where that direct heat is applied, once those molecules start to collide and become excited, it's sort of like a chain reaction. So, those molecules get excited and they start bumping into other molecules that aren't excited. But once they continually bump into these molecules, they become excited. So they start to bump into molecules, and then it just keeps on going. This is why if you leave a frying pan on the stovetop extended amount of time, this is why you can't touch the handle of the frying pan, because that heat that started off just being applied in certain places excites the molecules, and it eventually spreads all the way out to the handle. Another example of this that I used in my essay is when you walk on the beach. So the sun will heat up the sand, and once the sand is hot and you're walking down the beach, your feet touching the hot sand, that is a method of conduction, because the sand is hot, and when you walk on the sand, your feet will also become hot. The last example that I use in my essay to demonstrate conduction is an electric blanket. So when you use an electric blanket, you turn it on and it begins to heat up, and you lay it over you, and then you begin to get the heat off of that. And that is how conduction works, is because the molecules in the blanket become excited and they're directly in contact with you, therefore your body will heat up. Okay, so the final term to be discussed is radiation. Now, before we get started defining radiation and getting into the details of what it is and how it works and examples, there are some ways that you can think about it before that will help assist you in understanding what it means and how it applies to heat transfer. So, when you think of something radiating, you kind of think of something like a bicycle wheel, where there's a central point and spikes radiate from the center. Or you think of a flower and the flower petals radiate from the center of the flower. Or the sun. The sun radiates its light and its heat from its central point, which is the sun. So this is just a way to think about it before we actually get into details. So now we are going to start defining radiation. So radiation can be defined as emission or propagation of energy in the form of waves or particles. So another way to state this is that radiation is the transfer of heat through electromagnetic waves. And the transfer of heat through radiation means that it starts at an origin or a central point, like examples we talked about, and it spreads to a surrounding environment or a space surrounding it. So for radiation, I'm going to combine how does it work and examples because I'm going to use an example to really talk through radiation, how it works. So the first thing we need to understand is that objects that radiate heat have different degrees of heat radiation. So something like a cup of hot chocolate, that probably will not radiate the same amount of heat or energy as something such as the sun. Now, many objects radiate heat as infrared waves. Therefore, we don't visibly detect this radiation. So another thing that we need to understand is what is emission spectrum. So emission spectrum refers to the range of wavelengths emitted by an atom stimulated by either heat or electric current. So, as I stated just before that, many objects around us radiate energy as infrared waves. So when I say infrared waves, that means that they're not visible to the eye because we cannot see in infrared. Now, when an object's temperature is increased, the emission spectrum is decreased. So, this means that the wavelength, when the temperature is increased, the wavelength of those waves becomes shorter, the frequency is increased. So, a simple example of this is a stovetop burner. When you have a stovetop burner and it's not turned on, it's at room temperature. But when you turn it on, there is an increase in temperature and it's obvious and you can see it. This means that it's not infrared because it's visible to our eye. You can see it begin to turn a red-orange because it heats up. And the reason we are able to see this is because the emission spectra are shortened due to the temperature increase. This brings us to the end of my Physics Project 2 over understanding convection, conduction, and radiation. I hope that this has helped deepen someone's understanding of these three terms and how they work in the transfer of heat.